Hi everybody and welcome to this new video. If you follow my work, my blog, my Medium page or my YouTube channel, you can figure out that I usually make uncommon integrations between Unity and AWS. In this video, the integration I will talk about is an excellent fit because it will be between Unity and Amazon GameLift. But first, let me share an experience with you. Years ago, I worked for the game industry and I met a lot of very talented people. 3D artists, modelers, designers, UI designers, UX designers, independent developers, all working for small game studios. All these people could create and publish incredible games with Unity, but all of them, including me, struggled when we wanted to level up and create a real-time multiplayer game. At this time, Agar.io was very trendy and everybody in the industry wanted his own version of Agar. It has been a while, but here we are. And in this video, I will explain step by step how to use AWS services to build a real-time multiplayer game. When you start to build this type of game, something is obvious. You need a game server to connect your players. You could build this game server by yourself, but believe me, you don't want to do that because there is a lot of parameters you need to take into consideration. Latency, security, scaling, etc. It's a huge work. A great alternative to it is using a managed service for multiplayer games. In this video, I will work with Amazon GameLift. So what is Amazon GameLift? Amazon GameLift is a managed service for multiplayer games with the following characteristic. It deploys a set of EC2 instances for you. We call it a fleet. So you don't have to worry about mounting EC2 instances, securing them, etc. Second thing, it operates the EC2 instances for you, meaning that you will never have to connect to the instances or install anything. When you run a new fleet, a game server is automatically created. And at least it scales the service for you. No matter how many users your game is played by, GameLift automatically scale up or down according to the demand. So GameLift connects all your players together through a game server. It creates game sessions and player sessions. GameLift doesn't work alone. We need other services to make it work. So this is the architecture of the game we are going to build, and this is how it works. First of all, the Unity client joins the game calling a Lambda function. The Lambda function will work closely with GameLift, creating game session and player sessions. And then the Lambda function returns all the information we need to connect to the game server. So with those information, and I mean IP, UDP port, credential, etc. So with this information, the Unity client is able to establish a connection with the game server and the player is ready to play. So this is in a nutshell how it works. Now we will dive into each of those services. Let's start with the core service of our architecture, GameLift. Before creating a fleet, we need to define the behavior of the game server that will be automatically created. For that, we create a script that will be attached to the game server, and this script will basically do two things. First things, it will store player data and eventually update this data. By player data, I mean position, rotation, action performed, and whatever you need for a game. And second things, it will receive player events and dispatch those events. Very simple. For example, if a new player connects to your game, you need to tell the other player in order the client to update. For this video, I created a very generic script, so you can use it for all your games. But it's up to you to improve this script, creating, I don't know, teams, non-player characters, bots, some enemies or whatever. So what we are going to do, going to the GameLift console in the script section. So in the description of this video, I give you a script. So we are going to, this is a JavaScript script, and we are going to zip this script. So we compress, okay. We go back to the console and we create a script. The name, whatever, multiplayer script, version 0.1, and we upload a zip file. Okay, so this is a script we need. Okay. And then we create a new script. Okay, that's it. We have created a new script. We go now to the fleet section. And we can create a new fleet. We choose Manage EC2. We give a cool name, multiplayer fleet, and we choose the script we have uploaded seconds ago. Okay, we say next, and here we choose a region. So I will keep the default region US East 1. And here you have to choose a type of instance your fleet will be composed. So we will just keep the smallest instance and the cheapest instance, the C4 large. Next, here we are going to put the name of the script. Be careful, this is the name of the file. It's not the name of the script we gave in the console. So, okay, .js, and that's it. And we give no limit for the game session activation. Next, we go next, we review, okay, and we submit. Okay, the fleet is being created, is warming up. So we will see other services, and then we will go back to GameLift. Let's go now to Lambda. So why do we need a Lambda function? This is the entry point of our architecture, but what does it do exactly? The Lambda function works closely with GameLift. So first of all, when a player joins, Lambda asks GameLift if there is a game session available. If there is no game session available, a new game session is created. And if there is a game session available for this player, a player session is created and is returned to Lambda. So in which cases there is no game session available? It can be, for example, when there is no player in your game, there is no game session at all, so a game session needs to be created. This is the case. It can be when all the game sessions are full of players. The maximum number of player has been reached, there is no game session available, so a new game session will be created. Okay, let's go now to the console. In the Lambda console, we will create a new function. So, for example, multiplayer function, and we choose a runtime. In my case, I will choose Python, the last version of Python, but it's up to you to choose your favorite programming language. We create the function, okay, and we passed the code I gave you in the description of this video. Okay, so two things here we have to change. First of all, the fleet ID. Our fleet is warming up, but we can get the ID. So let's go to the GameLift console, and here, so our fleet is activating, but it already has an ID. So we copy this ID and we paste it in Lambda. Okay, second thing, the maximum player by session. Each game session has limits of players, and you set the limit. So, for example, if your game is an open world game, like Fortnite, you can define 50 or maybe 100 players by game session. If you are creating a chess game, it will be 2. So, in this case, I will set it to 5, and we deploy the function. Okay, two more things here in Lambda. First of all, the timeout of this function. So let's go to configuration and edit. I recommend you here to increase this value, because sometimes Lambda can be slow, the famous cold start. So I recommend you to increase this value to 5 seconds. Save. And then go to the permissions, and we need here to give permission to Lambda to access to GameLift. So we click to the role. Okay, so we have here the basic permission for Lambda, and we will add a new policy. We create a policy. Okay, so here you could you could use the interface to build your policy, but I gave you the whole policy in this video. So let's just paste the policy in the JSON section. Okay, we passed it, and you can see that we give permission to Lambda to access GameLift services. So, okay, we go next. We give a cool name, and we create the policy. Okay, so we go back to Lambda, and we choose the policy we have just created. So GameLift and GameLift Lambda policy. Okay, we add the permissions, and okay, that's it. So we are okay with Lambda. Let's now go to Cognito. Okay, so the question here is, why do we need Cognito? Remember that the Lambda function will be the entry point of our system, and we don't want any kind of restriction. I mean, credential, login, password, etc. The best way to give access to AWS resources, being a not authenticated user, like a guest user, is through an identity, a Cognito identity pool. So let's create the identity pool. Okay, so this time we will give access to guest users, but in the future you could activate the authenticated access if you want. For example, please log in to save the progress of the game. This is a very good use case. So we go next and we create a new role, and we go next, and we go next, we review, we are okay. Perfect. So then we enter to the identity pool and we go to user access. In the user access, we can check the related role. We click on it. Okay, so here we have to give permission to the Cognito identity pool to access to the Lambda function. So we add a new policy. We create a policy. Okay, so we could use the visual interface to create the policy, but I gave you the policy at in the description of this video, so we passed it. And here we have to pass the resource ID of the Lambda function. So we go to Lambda here and we copy, okay, the function ARN, and we paste here. Okay, that's it. So next, okay, we create the policy. Oh, and I forgot to give a name to the policy. So, okay, go next. Perfect. Then we go back to the role and we add the permission we have just created. Okay, this one, add permission. Okay, that's all. We are okay with Cognito. So that's it for the cloud part. Now let's go to the most exciting part, Unity. Okay, so for this video I have created a very basic multiplayer game with Unity. You can find the Unity package of this game in the description of the video. You can download it and install it. When you do it, you will figure out that some files are missing. You will get ugly error in the console. If you remember, we will call a Lambda function through a Cognito identity pool. So we need some AWS packages to make it work. In fact, we need the AWS SDK. We can find the SDK on the AWS documentation. We will download this zip file and unzip it. This file is basically a bunch of DLL files to connect to all AWS services. In this project, we will need only few files. What we are going to do here is creating a plugin folder inside the Unity project and copy these 4 AWS DLL files. First of all, we need the core files. You will always need the core files if you work with AWS, the AWS SDK. Then we need the Lambda file and the Cognito and the security token files who work together. Then you will need a library. If you remember, we will call a Lambda function. This call is asynchronous, so you need an extra package to perform an asynchronous call. You can find this package in the Nuggets website here and download it. We'll download the DLL files and import it to your plugin folder of your Unity project. Okay, so now we can connect to AWS, we can call the Lambda function, and we will receive some credential to connect to the game server. But you need some packages to connect to the game server. So let's go to the GameLift website, and you have to download the Amazon GameLift Managed Server SDK. So you download it and you can figure out that they are not DLL files. It's a whole .NET project. So you open the project and you just with Visual Studio and you compile it. you build the project. Okay, it's very fast. And then you can find the DLL file here in the release folder of your .NET project. So copy the files in the plugin folder of your Unity project. So there are 5 files, those one. So you copy the files, and now we are ready to execute, to run the game. Actually, we are not ready, I lied. Please first go to the util files of the project. And you can see that I stored here all the variables for the game. And we need the identity pool ID we have created. So let's go to the Cognito console, and you can find the identity pool ID here in the console. So we copy it and we paste it in the util files. We keep it. And multiplayer function, this is the real name of our function we have created, so this is okay. So now we are really ready. Let's run the game. So the game is running. We have here a main menu, and I will select the first character with character 1 and play. Okay, so here the credentials are being retrieved from GameLift, and the game server is matched. So I'm on the map. My character is on the map. I'm not a 3D artist, so I used free animation of Mixamo and free textures. If you are an artist, if you are a 3D artist, if you use Blender, if you use 3ds Max, it's up to you to create awesome maps and characters and animations. Let's try now with a second Unity client. I want to try the multiplayer opportunity we have. So let's try with a second client. I will use another Unity client and click on run. Okay, for this client I will use the old man play. Okay, as you can see, my 2 characters are on the map, and I can move forward, I can wall back, I can even jump or punch. The result is very good because I have a low latency. It's a real time, so I think it's a very good result. We are going to try now with a third client. So to change a little bit, I will try with, I have compiled the application in A7 device. So I will run the application, the Unity game, the Unity client on this device. For this character, I will use the girl, and I'm on the map. So I will run. Okay, as you can see, I'm currently moving my, controlling my character 3 from the device, the mobile device. So it's a very good result. We can even punch. We can punch. We can remove life from the character. We can jump, etc. So I'm not a game designer, but if you are, I have no doubt that your game will be awesome. If you use my game, please ping me, please send me a message. I will be very happy, very thrilled to see the results. Please use it, please improve it, please modify it and publish it. I will be very happy. If you go to the GameLift console, you can figure out that in the metrics section, you can visualize everything about your game. How many instances are running, how many game sessions or player sessions. So for example, here you can see that we had first 2 players, 1 player, then 2, and then 3 players. So at the end of the day of the week, you can check your statistic and see how many players do you have, and how many instances, EC2 instances are running, etc. So speaking of instances, in the scaling section, you can define what will be the minimum number of instances and the maximum. And between those two numbers, you can define how your fleet will scale up or down, creating an auto-scaling policy. That's it for this long video. I hope that you are still here with me, and I'm very happy to have shared this knowledge with you, and I'm very impatient to have feedback for this video. Please use all the code I gave you. There is no copyright, nothing at all. So please use it. Please use it for your game. Publish it and send me the result. I want to see the result. So that's it for this video, and see you in the next video.